Welcome to this video-based presentation with the title on Popper's falsifiability of Galileo's relativity paradigm through a photons-based real velocity measuring device. A real velocity measuring device will be indicated as RVMD throughout this presentation. Etienne Browns graduated at the University of Leuven in Belgium. He was a researcher during his full career, first at the university, then at the Belgian Nuclear Research Centre (SCK), and then at Vito. He contributed to national and international research programs. Part of his research is referenced in Scopus and ORCID. He retired at Vito in 2014. This presentation is based on the contents of a series of 3 follow-up Elsevier open access publications by Etienne Browns, as shown here. Regarding the falsifiability of paradigms, it is very important to refer to Thomas Kuhn and Karl Popper. In Kuhn's book, The Structure of Scientific Revolutions, scientists are considered to strictly believe in paradigms, while mostly neglecting anomalies, because the latter are very disruptive. A tenacious anomaly will ultimately demand an urgent investigation, forcing science to a new basis. The extraordinary episode, in which the paradigm shifts occur, is called scientific revolution by Kuhn. Karl Popper indicated that an irrevocable anomaly has an irrefutable falsifying value, overruling whatever type, or number of, experimental confirmations, of a contemporary paradigm. Einstein agreed with that point of view. In his first publication, Etienne Browns proved the existence of 2 massive theoretical anomalies. On the basis of Popper's falsification principle, he thus could falsify multiple, photon-based, contemporary paradigms. The contents of his first publication are the foundation of this presentation. The time slot of about 15 minutes of this presentation is however too short to go in detail. One is thus advised to read that free access publication. A major conclusion from that publication is the impossibility of a photon to inherit any velocity vector component from its source, in whatever direction. Such falsifies the equivalence principle for photons and leads to the concept of a RVMD. The key findings of this publication are now briefly discussed, while the concept of a RVMD is explained later in this presentation. Consider thus the minimalistic but nevertheless informative schematics of a setup, as shown in this slide. A reference frame x1, y1, is linked to an observer 1 at rest. A horizontally moving reference frame x2, y2, is linked to observer 2. A photon source is located in the origin S of the reference frame x2, y2, and emits photons in the perfect y2 direction. A plane is perpendicular to y2. The axis y2 intersects with the plane's midpoint M. The plane, photon source, observer 2 and reference frame x2, y2, move horizontally at the same velocity. Contemporary science keeps claiming wrongly that a photon inherits, moreover direction selective, thus only the photon source's horizontal velocity. Contemporary science thus still advocates this dynamic representation, claiming, erroneously, that for whatever value of the horizontal velocity, observer 2 will observe each photon, to travel on the ordinate axis y2, precisely to the location M. In order to be able to depict the displacement of the photons, moving in reality at the speed of light, the scales and timing, in this highly schematic dynamic representation, are of course overemphasized. It is however evident, from the findings in the first publication by Etienne Browns, that the claim, by contemporary science, that all photons will arrive in M, is totally flawed. Indeed, a consistent dynamic graphical representation of the trajectories of the photons, based on the irrefutable fact that photons cannot inherit any of the photon source's velocity vector components, in whatever direction, is shown here. It must be clear that the photons keep on traveling perfectly in their own trajectory, in the vertical direction in which they were emitted. That means that the photons will not arrive in the location M, as claimed by contemporary science, but in location F, as indicated in this dynamic representation. This leads to the fundamental static graphical representation of the photon phenomena in the moving reference frame. The graphical representation, at the right, corresponds to Figure 12 in the first publication by Etienne Browns, in his series of 3 interlinked publications on photon phenomena. A photon, labeled I, now arrives at T2, in the location F, thus not in location M. Remark that the now location of S in real space is mathematically not representative any longer for the past time T1 location of emission of photon, labeled I, in real space. Observer 2 can only virtually consider the location L, in a purely symbolical way, as the past time T1 location of emission of the photon, labeled I, in real space. Moreover, at the now time T2, a new photon, labeled J, is emitted, in the now location S, in real space. It must be obvious to anyone that the location S is not representative, in the reference frame of observer 2, as the locations of emission of all photons in the past time instances, in real space. The single now location S, in the reference frame of observer 2, indeed does not save all past photon emission locations in real space. This is the crucial error that has been made by contemporary science for over a century. Whatever type of mathematical reference frame approach, it is only existing as a virtual reality in the mind of the scientist. A researcher should always use mathematical models that save the real photon phenomena in real space. As proven by Etienne Browns in his first publication, several contemporary paradigms and mathematical models do not save at all the real photon phenomena in real space. A totally new mathematical modeling approach is thus needed, as demonstrated in this figure. The distance LF is representative for the trajectory length of each photon, thereby saving the photon's phenomena. That is moreover true for both observers and in both reference frames. The speed of light is thus simply the same for both observers, but from the now trivial point of view of having a photon trajectory distance equal to LF for both observers. Such also falsifies, in addition, the Lorentz contraction paradigm. Contemporary science claims the validity of its equivalence principle paradigm by stating, the result of any local non-gravitational experiment in a laboratory, in a free-falling status, is independent of the velocity of that laboratory, and its location in space. Our planet is in a free-fall mode, towards the Sun. So, contemporary science claims that the equivalence principle is valid for photon phenomena, in a laboratory on our planet. From this irrevocable graphical representation, however, it is now clear that for photon phenomena, the contemporary equivalence principle paradigm is flawed. The value of mf definitely increases with the scalar value of the velocity vector in the x direction, thereby indeed totally falsifying the equivalence principle paradigm for photons. This Popper's type of irrefutable falsification, by theoretical anomaly, of the equivalence principle for photon phenomena, was moreover supported experimentally, through a straightforward laser experiment, irrevocably proving the existence of an experimental anomaly, as predicted by this figure. All details can be found in the second publication by Etienne Browns, in his series of 3 interlinked publications, on photon phenomena. Due to the presentation time slot limitation of about 15 minutes, one is advised to read, in detail, that second, open access publication. The information is also available at the Internet, in video format. In short, mf varies linearly with the scalar value of the velocity v. If the scalar value of the velocity v changes as a sinusoidal function in time, then the value of mf will also change sinusoidally. Our planet offers splendid experimental conditions to introduce such a sinusoidal change of v in time. Consider a setup on our planet, of a fixed laser in a fixed grid. Contemporary science will state that all components in the setup are at rest, and that the location of the laser dot, on the grid, therefore also will be fixed for any time period, thus also at rest. That, at rest view, by contemporary science is flawed since our planet shows a very high Earth orbital velocity vector, indicated in short as EOVV. The scalar value of the EOVV indeed shows a staggering value of about 30,000 meters per second. Moreover, the angle between the EOVV and the direction of the laser beam will change during the 24-hour rotation of our planet. As a result, and as predicted, the laser dot was indeed showing a sinusoidal movement on the surface of the grid during an experiment of 24 hours. That falsified the view by contemporary science of having a laser dot at rest on the grid. The dynamic image of the sinusoidal movement of the laser dot can be downloaded from the corresponding Elsevier Mendel A reference in his second publication, or viewed within his MP4 video presentations, available at ResearchGate or at YouTube. In order to counter an eventual critique on the use of the EOVV, the remarks in section 3.4 in his second publication can be looked into. Those remarks involve the still undefined and complex combined effect of the multiple cosmological velocity vectors. The follow-up publication on the concept of a RVMD as a third publication was announced in section 3.4 in the second publication. The basic principle of the feasibility of a RVMD is straightforward, as illustrated here. From the measured value of mf, the scalar value of the velocity vector can be calculated. Two suggested schematics of a one-direction oriented RVMD are shown here. A photon being emitted at T1 will not arrive at T2 at the midpoint of the sensor. The location of arrival of the photon at the sensor is determined by the scalar value of the velocity vector of the RVMD, moving in real space. That location of arrival, therefore, allows to measure that velocity. This schematic dynamic image shows the trajectory phenomena of a photon in a one-dimensional RVMD of type 1. The basic principle of a one-direction-oriented RVMD can be expanded to a three perpendicular axes-based RVMD. Such three-dimensional RVMD then allows for the measurement of the three scalar values of all three velocity vector components. A three-dimensional RVMD, mounted on a material object that moves at a high velocity in real space, thus would allow to measure the full velocity vector of that object. The basic mathematic velocity vector calculations for a three-dimensional RVMD can be found in the third publication by Etienne Browns. There are multiple important potential applications of a three-dimensional RVMD in space and on our planet. Such RVMD will allow to measure the real velocity vector of material objects moving at high speed in real space. Such objects can be a planet, a moon, a spaceship, a hazardous asteroid, and so on. It is obvious that a three-dimensional RVMD, mounted in the confined enclosure of a spaceship, will enable to measure the full real velocity vector and direction of that spaceship, without any need for an outside reference. A RVMD can therefore be considered as an irrevocable Popper's type of anomaly of Galileo's relativity paradigm, thereby fully falsifying that paradigm. With respect to our planet, a three-dimensional RVMD will enable to measure the full EVV, thus the Earth's velocity vector, directly including all other cosmological velocity vectors, as explained in section 3.4, in the second publication, by Etienne Browns. Such will allow to improve multiple observation applications on our planet, based on photons, which are sensitive to the effect of the EVV, on the photon trajectory phenomena, in real space. As an example, Etienne Browns has discussed the importance of the input of the three-dimensional RVMD, EVV measurement data, in the calculation software of high-accuracy theodolites. The effect of the EVV, on an angle measurement, is estimated to be up to about 20 arcseconds, while the claimed angle measurement accuracy, of a high-end theodolite, is claimed to be 1 arcsecond. The EVV effect is thus to be considered as a systematic measurement error, which seemingly is not considered up to now, and should be tackled. As a conclusion, the R&D of a three-dimensional RVMD should be considered as fundamental. A R&D project can only be done by a broad team of experts involving physicists and high-tech component manufacturers of lasers, optics and mirrors. Expert engineers in electronics and computers, involving CCD devices, computer hardware, and so on, are needed. Software specialists, mathematical modeling experts, and many more, are required. It is now up to the scientific and industrial community to take advantage of this massive R&D opportunity.